Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like and share the channel. To receive a notification when I upload new content, please subscribe to the channel and click the alarm bell icon. Please leave a comment if you enjoy this video or have anything you'd like to share with me. In the description below the video, you'll find a link to print the math handout I am using. In this video, I'll be going over problem number 13 from the Chapter 8 Combination Circuits math handout. So here we see our combination circuit, and we have two series parallel strings. We have branch 1 here with R1 and R2. We have branch 2 here with R3 and R4. Over here you see the steps that I will be taking to solve the equations, to solve for all the values in this circuit. The purpose of these steps is I want you to rework this circuit from scratch, cover up the steps, and if you get stuck, you can look at the steps and see what your next step is. So write these steps down, have them handy, but don't look at them when you try to rework the problem. Alright, so since this is a basic combination circuit and it is not a random unknown, our first goal is going to be to find RT. We're going to go about doing that. Well, if we look at these two resistors here, we'll see that R1 and R2 are in series with one another. So we're going to add those two together. And we see that R3 and R4 are in series with one another. So we're going to add R3 and R4 together. So when I redraw this circuit, and this is a circuit that you have to redraw. Personally myself, I have to redraw this circuit in order to be able to do the calculations. So in my first redraw, what I have is R12, which is 220 ohms. I get that value by adding R1 and R2 together because R1 and R2 are in series. R3/4 is 2.2 k ohms. I get that by adding R3 and R4 together. Now I have 220 ohms in parallel with 2.2 k ohms. So I'm going to use my reciprocal formula, 1 over under, 1 over under, 220 ohms. Scroll over, plus 1 over under 2.2 k ohms, it equals, and my RT is going to be 200 ohms. So I can fill in the blank right here, 200 ohms. Now anytime I can get 2 out of 3 going horizontally across here, if I can get 2 out of 3, I can solve for the third. I'm going to save power till last, so I can go ahead and solve for the IT. 120 divided by 200 ohms gives me, hit engineering, 600 milliamps. So I can fill in the 600 milliamps. Now in this particular combination circuit, I can't go any further. So I'm going to focus on drawing B here. And what I'm going to do is I'm going to take the VT and I'm going to apply that across branch 1, giving me a V12 of 120 volts. That's my VT. Then I'm going to take the V34, it'll be 120 volts. Apply it across branch 2. All I did was take the VT, put it across branch 1, take the VT, put it across branch 2. For right now, just act like drawing B is where you started, and that's the only drawing you have. So you got 120 volts over 220 ohms and 120 volts over 2.2 k ohms. To get a better understanding of this, if we look at how the current is going to flow through this circuit, when the current leaves the negative post of our DC power supply, and it gets to this point right here, and it starts to turn and go up through branch 1, go all the way back home. Well, what happens is when it comes to this point right here and it starts to turn and go up branch 1, it sees the total resistance of both of the resistors. The current is not going to flow through R2 and then see R1. No, as soon as that current takes a turn right here and starts heading north, it sees the full 220 ohms of resistance. So that tells us that the amount of current that can flow through branch 1 will be limited by the full 220 ohms of both of these resistors put together. So if I take my 120 volts and I divide it by 220 ohms, I get the total current that will flow through branch 1, which will be an I12 of 545.45 milliamps. That's how much current will flow through branch 1. For branch 2, which includes resistors R3 and R4, how much current will flow through this branch, this resistor right here representing both of these resistors. So how much current would flow through that branch? I would take the 120 volts divided by 2.2 k ohms, and that would give me 54.54 milliamps. Now if we look at the current flow here, whatever amount of current leaves this point right here and starts going this way, all of that current has to flow from this point to this point. It cannot leave this branch anywhere. It all has to flow through R2 and R3. The full 545.45 milliamps has to go from this point to this point. So that tells us the current of I1 and I2 will be the 545.45 milliamps. The same thing will take place on branch 2. Whatever current is coming this way, it has to go through both resistors because there's nowhere else for it to go. It can't exit anywhere. So once it enters this pipeline and starts turning this way and going up this pipeline, it has to go through both resistors. There's nowhere else for it to go. So when we calculated our 54.54 milliamps, that told us the amount of current that will go through R4 and R3. How did I get these numbers again? By taking the 120 and dividing it by the 220 ohms. The 220 was the addition of R1 and R2 put together, added together, because R1 and R2 are in series. Where did I get the 2.2K from? I added R3 and R4 together because those two are in series. And then I just take the VT and I apply it to both resistors. Because that is, if R1 will drop some voltage and R2 will drop some voltage. And whatever the voltage of R1 and R2 added together, that will be 120. However much voltage R3 drops, however much voltage R4 drops, if I add V3 and V4 together, that will add up to 120. So now I have I1, I2, I3, and I4. So now we can see that we've got 2 out of 3 here, 2 out of 3 here, 2 out of 3 here, 2 out of 3 here. So now I can just use Ohm's law and take the 500.45 milliamps times the 100 ohms, 545.45 times 10 to the negative third, times 100 ohms. That gives me 54.54. We round the second number after the decimal. That's how much V1 will be. For V2, I'll take the 545.45 milliamps. I put a little extra number here. All right, 545.45 milliamps. Now I'll do it times R2, 120 ohms. And that gives me 65.45. If I add 55.55 plus 64.45, 0.45. That gives me approximately 120 volts. It's a little bit off due to the rounding. So the amount of voltage that I drop here and here will add up to 120. Let's do the next one, 54.55 milliamps. So we'll do 54.55 times 10 to the negative third times, what I'm doing right now is V is equal to I times R. So here's the I times, let's put the R in, 1.2 times 10 to the third equals 65.46 volts. Now I'll put in R4, which is 1K ohm. So here is my I4 times my R4, and it'll give me my V4, 54.55 volts. So V1 plus V2 will give you 120, V3 plus V4 will give you 120. The power formula, PT will be equal to IT times VT, just the basic power formula. PT equal to IT times VT gives me 72 watts. P1 is equal to I1 times V1. P2, I2 times V2. P3, I3 times V3. P4, I4 times V4. With our power formula, we can check our work. If we take power and IT times VT gives us the same answer as P1 plus P2 plus P3 plus P4. That's a good way to check our work, and our calculations should be correct. I have here 3 blanks. These are the ones that you will enter into the Canvas answer sheet on Canvas for Chapter 8. And this is how you work a combination circuit with 2 series parallel strings.